yes, doors can be very interesting, like anything actually in a car, if you just pay close attention and also respect and imagine the amount of work, energy, sweat equity put by thousands of engineers and technicians all over the world to put them on our streets and make them usable item in our everyday life. A2Mac1 is a company, is a commercial company. As Oscar explained, I work for them since 2018, and we do something a little bit special. We do a lot of testing, tear down and costing of different kind of mobility objects, mostly cars, but not only. And we serve different kind of customers all over the world. So in the end, we are mostly a data and consulting provider. And a lot of things are available. I will spare you the details to talk about those and focus on that topic. I just utilize some of the data that we have at our disposal to enable our customers to do basically two things: target settings in early design stages of a project, or value engineering to challenge their own ways of doing and find more efficient, more cost-effective ways of designing or manufacturing their parts or systems. Whenever you see those icons, those are the products that we are using. So when Oscar asked me what would I want to present, I had some material already available that we had shared with some customers. One of them was about door design. And it's actually, I think, very interesting because when you approach a car, that's really the first thing that you're going to hold. You see the car in large. The doors are contributing to its overall styling. They all have their specifics, their styling cues, their purpose, their message, you know, depending on the design intention of the engineers and manufacturers behind those products. And all of them have something in particular to tell you. Then when you start to look into the design details and you separate the door, see it in isolation, they also have their specifics, whether this is about conveying a purpose, conveying a message, putting the car at a certain price point as well, due to specific options, specific perceived quality features, a lot of or practicalities, depending on the product positioning. The design features and functionalities of the door can come in play. What is nice with doors is you could say it's kind of a summary of the automotive industry within one system. You have Class A styling surfaces, you have sheet metal parts, you have plastic, you have leather, you have glass. They can serve different kind of purposes. It can be safety, it can be security, it can be perceived quality, acoustic comfort, aerodynamics, anti-corrosion. Whatever their purposes, you can see that, in fact, whenever we approach the car, systems such as the doors are always very interesting to pay attention to. In the end, we kind of boil down those technical features of function into certain bottom line KPIs. That could be the weight, potentially the cost, but also we could extend it to CO2 equivalent. That's obviously one of the key areas of interest for our customers. So the first thing that I was wondering when preparing this presentation is doors can be very diverse. As the few examples I showed you, I think embraced a pretty big diversity of products that we have the opportunities to tear down to the bits and pieces that you see on the screen and analyze them. Some of the cars on top of that are benefiting from the additional analysis from a body-in-white standpoint. In that case, we take the door structure, the frame, and we'll tear it down to tell the outer panel from the door inner, the reinforcement, the window frame, the door beam, the anti-intrusion beam, from the rest, you know, from the complete structure. But all in all, as you can see, those are a lot of components that are there and that we can analyze. And from a weight standpoint, if this is the KPI that we want to focus on, as it leads to cost, as it leads to total weight of the car, total efficiency of the product, but also eventually CO2 equivalent, you can see that the door structure is a great contributor. In this case, this is a Golf 8, so latest generation that we processed last year. So down to the body in white, and you can see somewhat the distribution of the various component weight. The Golf, it's a very popular car all over the world, in Europe in particular, but I think not only. And we have a chance over the past 20 years of the existence of the company to have toned down many generations of Golf And that's always interesting because it tells us a little bit about the strategy applied by the manufacturers and the impact of legislations, for instance, related to CO2 emission, that would have on their design practices. A lot of the decisions of the manufacturers have to do with the car that they want, the product that they want to put on the market, but obviously also the regulatory constraint that is pushing the decision one way or the other. In general, you can see that over the years, when you think about a Golf 8 or Golf 5, 6, 7, then down to 8, they've been initially early 2000 an effort for weight reduction, but basically, eventually everything stayed the same. Why? Because the product didn't evolve so much. Here, the main rationale is cost efficiency, carryover, reuse, and a lot of things stayed the same. You could tell it just by looking at the various generation of Volkswagen Golf. They are a Golf. They have a distinct style that make them what they are and appealing as they are. Ironically, when we think about the ID3, which is portrayed by this very manufacturer as the electric Golf, if you want, the kind of compact family car that could be a mass volume product. Here, the trend seems to be reverted. Suddenly, the doors become bigger, and it's a bit of a surprise considering the car itself is vastly more heavier than the traditional Golf, mostly due to the battery system. And obviously, the weight is not only due to the technical features, it's also due to the overall styling. And it turns out that the ID3 is a bit of a bulkier, taller, CUV-ish vehicle that is also offering this other kind of interior space compared to a traditional internal combustion engine compact car. That's also a way to differentiate one from the other, to connect, what we observe with the trend of electrification. If the same family car was having the same value proposal, quote unquote, to reuse the marketing buzzword that you hear all the time, then you might be wondering why you just spend 30% more on an ID3 compared to a Golf 8 for having a range that is less. It doesn't mean that when you look at the detail of a door of a Golf 8 and an ID3, there are no effort of weight reduction. Weight being often perceived as the enemy of mobility, the enemy of efficiency, the enemy of range, the enemy of CO2 equivalent and emitted CO2. When we section some of the key components of the car, just to see their makeup, not only in terms of fasteners, but also in terms of layering, if you want, and assembly. And when you look at the Golf 8, it has the traditional feature of a plush door experience. When you put your arm on the armrest, it feels comfortable. It feels like what you would expect from the promise of a Golf across decades of existence. With the ID3, it's a little bit different. You can see that there have been some cost-saving effort. For instance, the padding on the armrest is a bit less. The lower part of the door would not be covered with foam layers, simply to reduce cost. It reduces perceived quality in terms of touch, in terms of look and feel, but eventually that's also the kind of the trade-off that manufacturers have to make to put cost-effective products on the road, despite the overall increase of the weight. And you can think then the raw material and cost, you can also see locally where they try to find the right trade-offs in terms of function and in terms of comfort. This one I'll skip. What is interesting looking at a car is, first, its overall dimension. They are related to the end product itself and its positioning in terms of being a family vehicle or personal vehicle, but also its technical attributes. How has it been made? So you can see here a lot of the technical and functional and dimensional attributes that we can use to describe the door. And here you might be wondering then if the door comes from an electric car or from a plug-in hybrid or from a SUV, from CUV, from a compact segment, subcompact, or larger types of cars. So once you do this kind of work and break apart a door and have in mind the kind of vehicle that it comes from, it allows you to do some statistical correlation. And I was working a bit with the numbers And you can see, for instance, the kind of correlation that they've been trying to do with the following idea. Imagine that you are designing a brand new product. You draw a sketch in your CAD system, and overall dimensions are set depending on your styling intent. You might make a few engineering technical decisions. For instance, the material of the door. What is the cost breakdown? What is the targeted cost of the door? All right, I know I cannot use aluminum, or I can use aluminum. So imagine you have those few boundary conditions as a design engineers. Other scenario, you are looking at a competitor on a fair. Let's say at the next, I don't know, CES event in Las Vegas in March next year. And the manufacturer is there showcasing great innovation, and they have a door. And you just look at it and you're wondering, what would be the weight of that door using a few parameters. So for instance, you could measure the door, and with a simple magnet, you can put it on the door. If it sticks, it's steel. If it doesn't stick, it's aluminum. You know what I mean? Like big level criteria. Well, in the end, you can see that depending on how refined you break down and the quantity of design attributes or geometrical attributes you are taking, the correlation can range from very poor to actually quite good, depending on what you want to correlate. In this case here, looking at the door itself and its heaviest largest weight contributor and cost contributor, that will be the door frame. You can see that depending on the circumstances, for instance, steel material, then you will be able to correlate, to link one with the other fairly easily. I'm not the only one doing this sort of things. When you deal with benchmarking, these kind of methodologies are used heavily. You have academic material available using it to map on data, in this case coming from the University of Michigan. You have here the title of the publication that you can utilize, and you can see the way the models have been built, correlating weight of doors or all the closures of the cars, rear doors, hood, tailgates, with technical and dimensional attributes. And eventually, why I like this kind of method is the challenge of tomorrow when thinking about electrification, as I said, will be weight, but also therefore conveniency for the customer, meaning range. And we can see a lot of legislation thinking about end-to-end CO2 emission. Therefore, CO2 emission, building models to go from what we observe to this kind of KPI would also be, I think, very important. And I don't think we can do that without looking at the subsystems and their technical features. There are other ways to correlate the weight of a door with other attributes that are purely dimensional, like done in 2021, mid of this year, in the Technische Universität München. We helped that student by providing some data, and he has been able to do some correlation, as you can see, using the vehicle height or the vehicle wheelbase. And here I picked up just the formula that he was establishing to assess the weight of front door or rear doors. But that kind of approach is interesting for reference, but doesn't go up to costing and CO2 equivalent. Then when you do this sort of exercise, you take a macro perspective at door design. We have 1,000 doors in our database, so it's very interesting to have many, many functional attributes, but also characteristics of the cars, generations, OEMs, body types, and so on to the work. And sometimes you get curious and you zoom down to one OEM in particular to be able to understand if the strategy has changed. And here I elected BMW. Not only because I tend to like this brand, but also they have an interesting approach, and they're also good customers of ours. But anyway, they are a good candidate for being scrutinized. So you can see the way some of their products is in fact located on this plot. In this case, I just chose a couple of attributes because I think they were relevant to highlighting or illustrating their strategy. The door frame mass versus the complete weight of the door. On the one hand, you have, I would say, exceptions to their product portfolio, which is the BMW i3, which has been discontinued, basically one of their first volume electric vehicles. And then you have a lot of products across the ages that basically illustrate that now the strategy of BMW, even for compact SUVs, electric, for instance, like the iX3 or the BMW X5, the strategy of this manufacturer is to move from steel doors to aluminum doors. That's a generic trend that we see not only with BMW, with quite a few other manufacturers. By the way, I'm wondering if this is going to stand the test of time. As we know, the CO2 equivalent for aluminum tends to be greater. Depends on how aluminum is produced, obviously, but it tends to be greater than steel. Across time, also quite interesting to see how the door frame has been manufactured. And here, the interest of this kind of slide is to show you two things. All in all, the bottom line weight. So you can see if whenever you will open the door of your car next time, you will look at it a bit differently, I'm sure, because you will now see that it's quite heavy. In fact, you can see that if it's made of aluminum, and if you are fortunate enough to drive the BMW X5 latest generation or 5 Series, the door frame alone would be around 10, 11 kilograms. But if you have an older car where the door is made of steel, you can see up to 18.6 kilogram. So material, weight, and then also something that is interesting that you can observe is the anti-intrusion beams, the way it has been implemented in the car. They ensure safety of the passenger, of the driver in case of a lateral crash. You can also see the way the cutout is done in the door. Kind of narrow here, and some of the stiffness of the door is ensured by the sheet metal of the door inner itself. But as time moves on, you can see that the cutout is wider and wider. And that's something that is interesting in a sense that they need then to fill this hole by what they call a function carrier. And here the strategies, depending on the OEMs, are varying. You can see Mazda tried it and they revert. Apparently they had some noise cavitation issue within the door, which BMW, by the way, didn't have. We know that this approach is interesting, often done in Europe and in China, not so much in the US, not so much in Japan. And yet it facilitates the production cycle. It makes things a little bit easier to mount on the door. What you would have on this orange part that you see right now on the screen will be a whole set of equipment such as the door sound insulation, if any, the speakers, potentially the window rails to enable window drop scenario when it goes up and down, and then, for instance, the lift motor. It allows also for weight reduction. All in all, when you do the math, it seems to be there. And some of the NVH issues that other manufacturers have addressed, I believe BMW addressed them by padding the outer rim of this plastic part with a seal that both seals but also ensures a vibration absorption, and that is not then transmitted to the door and to the cabin, therefore to the driver and the passenger. So interesting approach. Not unique to BMW at all, but you would see that other manufacturers are doing differently. Actually, I can maybe show you a quick example. That's you will recognize this latest Hyundai Tucson model 2020-21. I'll just show you what it is on this kind of car. If it reacts, yes, it does. Just to show you a counterexample of other strategy, hopefully it will show up. I guess I'm doing too many things. I'm also not plugged to the power supplies. Okay, if it comes back, I will show you a counterexample of this strategy. But in fact, look, talking about doors, talking about door frame is also for me a way simply to sidetrack a little bit and talk about passive safety. I was mentioning before the anti-intrusion beam, or also called door beam. You might have noticed that on the BMW X5, across time, either it was bolted to the door housing or welded. But in the end, the strategy of BMW is always to implement some sort of a beam that is an open section beam and made of steel, even though the door might be in aluminum. And I was wondering, looking at that, as it speaks to safety, also maybe the promise of a more sustainable mobility. You know, if you project yourself to electric cars, protecting nature, also a lot of OEMs have pledged 0 casualties in their car on top of CO2 neutrality. So I think the whole story blends together into a smarter, safer mobility. And I was wondering, what do the other OEMs do? I spare you that we do some sort of simulation as well on crashes. And I was wondering what were the other options available on the market. For instance, when you look at all the kind of products like on Toyota, but also at Tesla, you would see a single beam being used. In this case, it's a tubular beam, therefore probably pretty cheap to manufacture, even though the material ultimate steel strength is pretty high. You can see almost 1900 MPa. Other OEMs like BMW on the X5 and others, but also Polestar are using an open beam and just one. Other manufacturers that I haven't confirmed yet on the latest generation of the Nissan Qashqai, we have received it, but I didn't have yet the time inclination or even I didn't remember it. But I could confirm if Nissan by any chance has changed its strategy. In this case, they are using two beams. The other one that you see, by the way, are simply used to ensure the door rigidity itself or to support various sort of equipment, as we have seen before, like the sun insulation, the window lift mechanism, and so on. So those two beams have high UTS. Therefore, my assumption is that they are key contributors to safety and anti-intrusion. And you can see in this case two tubular beams. At Mazda, another approach seen in this case on the Mazda 3, likely on the XC30, and likely as well on the front door of the MX30. I didn't check any other of their products. In this case, the beams are open section, and two of them. Usually, they are slightly curved outwards, and they are meant to basically transfer the energy of the shock downwards toward the substructure of the car. Also, we have the chance to have teardown centers in the US, in France, in China, in India, in Thailand, and I missed one, in Korea as well. Sometimes we import cars from Japan or from South America also to see local specificities and take interesting samples from all the cars in the world, so much diversity, in fact. And for instance, if you take a Honda HR-V, so not the latest model that we will receive early next year in our American teardown center, but the older version, I was wondering, well, legislation are different, right? The side impact tests are different depending on the countries. In the US, I forgot the conditions, but if I recall, the impactor is heavier and the speed is greater than in Europe. And how does it convert into the technical decision done by the manufacturers that need to juggle between compliancy and cost? And guess what? You find example where, in fact, the material quality of the second beam is vastly decreased. You can imagine that the American solution is more resistant to side impact, but probably more costly to the manufacturers in terms of thickness and material and steel quality. Not blaming Honda or assuming anything about their intention, but simply they try to comply. Certainly they do. And they take the decision going along with the legislation to maximize their opportunities to reduce cost and maybe spend the money somewhere else. Something specific to Volkswagen, not only the ID.3, but many other Volkswagen cars, they add on top of the window frame what you call a top roll, as you can see, with a high UTS. In this case, the oblong section that also we believe is contributor to a crashworthiness or safety of the passengers. That's something specific to Volkswagen. We don't see that with other manufacturers. By the way, why? You might be wondering. I don't have the answer. Maybe some others are achieving the same level of efficiency without this kind of system. Maybe Volkswagen has established practices, validation protocols, assembly lines that are using this ID. They are the only one to use. We can't really answer that question, but that's just an observation. We had the chance to process the MX-30 from Mazda, their first electric car, and it has an antagonist door, also known as suicide door. In this case, what is interesting in this kind of setup is that the rear door, as you've seen so far, I've talked only about the driver front door. It's a choice. I can't overwhelm you with so much. But the rear door is interesting. I understand it might be a constraint if you are used to 4 doors, as you cannot open the rear door without opening the front driver door. But if you are used to European small car with 2 doors, the rear opening is a blessing because it makes the access of the rear seats much easier. However, it means you don't have any B-pillar. So how do you ensure the crashworthiness of the car in case of the side impact? In this case, as you can see, the B-pillar is embedded in the rear door. Not unique, that's how you should do it. We've seen that also on the Volkswagen ID3, BMW ID3, for instance. It has consequences. For instance, the rear windows cannot be lowered. So if you are claustrophobic, don't sit on the rear seats of the Mazda MX-30. Yes, and also the way you need to put the safety belt, that could be solely, by the way, on the seat, has to be relocated, just like what they have done. It cannot be on the V-pillar, obviously. It cannot be on the door that is open. So they need to find it another way on the door, actually at the bottom of the door. All right, so we talked a little bit about some manufacturing consideration. I wanted to continue with this safety theme, but this time moving ahead and maybe accelerating as well on manufacturing perspective. We have deeply torn down about 90 cars, including body in white. In total, 1,000, but across the time we went further in the body in white domain, including all closures. And it's interesting to see the combination of material used for the door and material used for the beam itself, just to see what was the diversity. I thought it was an interesting story to tell. So here there's quite a lot of cases where it's all steel or all aluminum, but you also have a blend. So all aluminum would be the Tesla Model 3, Model Y, the Mercedes Class S, the Jeep Rubicon, for instance, Renegade, sorry, not Renegade, Rubicon, the pickup truck. What else do you have? The Audi e-tron also, it's full aluminum, including the beam. And then the Jaguar I-Pace is one of these cars distinguishing itself with a blend of material. And in general, the I-Pace is interesting because it was the first electric car from Jaguar, probably the first European electric car from with that level of ambition, if you exclude the old Zoe and the BMW i3, in terms of being a premium D-segment car. You can see a blend not only of material, but also of manufacturing processes, casting, stamping, extrusions, depending on the doors. And you can see here, for instance, on the door frame, the use of cast aluminum. That is something that we had not seen in other cars. By the way, you see the same kind of die-cast aluminum strategy on the body structure of the I-Pace itself, in the A-pillar and on the front unit. How do you call that? Torsion box. The way to assemble those various systems in all doors, outer and inner, for instance, it's pretty much the same all the time. If only for one reason, you need to ensure visual perceived quality. So meaning you cannot have spot welds. You might see them. It might look ugly. So usually the way you would assemble and close up the door between the door housing and the door outer shell would be by hemming or adhesive or combination of the three. Sometimes when we see adhesive, we assume they also have a sealant function. We simply cannot tell simply observing the material that we don't test those materials themselves. But basically, this is the way to go. But there are exceptions. This is the fun part of benchmarking, is to look at the crazy stuff that others are doing differently. And we can see, for instance, on the Jeep Renegade, some spot welds on top of hemming. So we assume that here for pre-positioning the door housing with the outer panel of the door. And then you have special cases like BMW that is using brazing. Likely, it's probably very expensive. Probably they already spend the capital to buy the equipment, and they keep on using this assembly process. It has one key benefit, is the way you handle cornering will be not meant of made of folded sheet metals, but basically it will give you a cleaner result. And we assume this is also why they want to keep on using this process, contrary to most of the other manufacturers. Something also a little bit specific. I don't know if you understand what I mean by tailored blank, but it's when the blank that you use, that you stamp, would end up having different thicknesses. It might be used, for instance, on B-pillar to provide a crumple zone that would fold under a crash, under an impact. And it can be the same also for doors, but also it has a side effect, which is lightweighting. So we can see here on the Honda E that the hinge part of the door is thicker, and you have this zone that will fold under longitudinal effort, and also that allows the second half of the door to be much thinner, even though the material quality is the same. So they probably save maybe close to 1 kilogram with this kind of methodology. And when you look at all the doors we have, they are the main user of this method, at least for doors, not for all the subsystems, as I was mentioning for B-pillar, for instance. We see that at Audi, just to give an example, or Mercedes. But on those, it's mostly Honda that does that. We don't know if it is because we simply analyze more Hondas and they happen to be overrepresented in our sample. It's a possible issue with our sampling of cars. Other manufacturers are doing that, but Honda clearly have that as a strategy. I'll spare you this just to save a bit of time and give you one example that is also relevant to the rest of the activity of the Design Society and the Design Practice Group, as we are looking into Industry 4.0 impact on engineering practices. And then I was thinking, what about additive manufacturing? As of now, we haven't seen anything really significant in any of the cars that we have analyzed utilizing this technology. That is probably so far still bound to be limited to low volume. And I couldn't find anything but apart from public information on the front door of the BMW i8, which is discontinued and has been produced in very low quantity. As you can see, this is one of those cases where the two guides of the window frame that you can see here are so close to one another in the center of the door that they need to be an additional guide. Otherwise, the window will be well supported. And this part has been done using additive manufacturing. There's a very good video from BMW on YouTube. Frankly, that's the only example that I've seen relevant to those. I've seen other examples elsewhere in the car, but frankly, nothing very significant. So what does that tell us about electrification, and how does that mega trend impact door design? I've talked about weight. Weight equals cost. Later, material selection and weight and quantity of material and process will equal CO2 equivalent along the life cycle of the car. And obviously, it's hard to talk about electrification without an overarching topic of sustainability. Needless to say that transportation is not only that. There are also other important trends to put into perspective, especially autonomous driving. And it's hard to tell one with the other. Once again, my contention is, if you pay 30% more on an electric car, you as a consumer would expect more than the same of the same with a different engine and less range, a different motor with a less range. There is likely a requirement for addressing all those other trends, but new ways of designing cars on top of what the platform, native EV platform, might offer, to make the entry in the car something that is worth the money, the extra money you spend for an EV. There might be a reason why you go for EV. It can be tax. It can be the fact that your city doesn't accept anything else, or your conscience is speaking to you. Many reasons, but I think the whole story of mobility is changing in all those four directions, and it's hard to tell one from the other. Let me try to break it down with a few examples related to doors that support the idea that mobility in general is changing with electrification as I would say a core driving change. Here you can see 4 electric cars, and it turned out that all of them have suicide doors. Usually see them only in a few examples that I talked about before, or during in concept cars, because it allows you to see the interior space, which is one of the key selling points of electric cars, as the platform allows you to move the wheels at the four corners of the car. More space can be allotted to the inside of the car, and therefore, I don't know who is pushing the button for me, but you can please not do that. And therefore, you have more space inside, and if the doors are opening widely, then in that case, you can enjoy more the interior space offered by your EV. Some manufacturers are going production with other kind of models that the posts are precept, and I'm curious to see if more will do the same. A side example that has nothing to do with EVs. I don't know if Scara was going on, but the slides are going forward on their own. This car is interesting. It stands out in, I'll do it this way in that case. I'm sorry, I'm having maybe a bit of a glitch. The slides are moving forward on their own. I hope you can still see my screen in a comfortable way. So this cloud of point represent all sorts of cars, electric or not, and there was one that stood out. It's nothing to do with suicide doors as such, but simply I'm just seeing that depending on the purposes, you might have ways to have the doors opening wide, welcoming people in the car, or facilitating loading the car with goods or children. And the Tata Altroz, which is an internal combustion engine car, stands out. As you can see, the doors are opening 90 degrees, and it's kind of an exception among all the others. Again, nothing to do with electrification as such, but simply an interesting highlight, a fun one. When you think about autonomous driving, and if I try to see, what do we observe today in today's car that could speak to this trend? Here's an interesting example. The BMW X7 has heated armrest, not only in the central console, but also in the door. So I thought, okay, this is a premium, very expensive car, but what if you project yourself with autonomous driving and imagine the third living space, as manufacturers tend to call it, where you really want to be comfortable, and the armrest of the door is contributing to conveying this feeling of being trusting that the car doesn't crash, because it drives on its own, but also being seated comfortably in a warm environment. Interesting design solution that we might see being popularized elsewhere. Something else as well, when you think about autonomous driving and also linked to electrification, the glass on the windshield, but also on the doors, tend to adopt what we call acoustic properties. So it means you have a PVC layer between glass that absorb vibration and make the cabin more soundproof. For the first time on that kind of electric car and this kind of segment, we have seen windows with acoustic properties in the rear doors. Normally it's windscreen and front doors at best, but not the rear doors. That's something special that we've seen on the Ioniq 5, and probably something that we'll see more and more as the car becoming silent, as you want them to drive on their own. Ioniq 5 is only level 2, but moving forward, electrification and autonomous driving together probably speaks for greater acoustic comfort in the car. We can also see side mirrors changing to cameras. A few examples do exist already in our database, including Ioniq 5, by the way. But in like 2-3 years ago, we had a Lexus that had that, but the Honda E and the e-tron have this kind of features. In this case, it's about trusting, educating you to trust to look at the world through a screen and a camera. I think we are all getting there, and including for changing lanes. In this case, it turned out that the display can be embedded in the door. It's the case on the e-tron, as you can see. By the way, it's positioned very low. On the Ioniq, it's also on the door, but then the screen is a bit higher. In Honda here, it's in the dash. So some solution impacting door design that are relevant to other kind of megatrends. Also, the pitch of our idea at the time was, because the side mirror is smaller, it reduces the frontal surface of the car. Therefore, it is increasing the range. We did the analysis through CFD. We cannot confirm what they have said, but indeed it reduces the frontal surface by a bit less than 2%. we still have to deal with a car that is 2.2 tons and anyway an SUV. I also was wondering in general if you want to reduce the frontal surface, you need to have a car like a Countach, or like what you see on the Corvette with very tilted windows to have a very small, sporty front surface. Not really the case in the EVs that we see today, because you still have to think also about practicalities and interior comfort. And I think if we sell an electric car only with the notion of efficiency from an engineering standpoint, then you end up with something that looks like a water drop, but not maybe a family car for daily commute or enjoying long journey. So you can see that the extremes between the Jeep Gladiator and the Chevrolet Corvette, kind of both ends of the internal combustion engine spectrum, this logic doesn't really apply to EVs that have more to offer than being a powertrain on battery. However, the design of the door can have an impact. Depending on how they are done, you might have surfaces that are perpendicular to the airflow, creating higher pressure and therefore increasing drag. So a lot of EVs, for instance, like on Tesla, tend to have flush windows where you don't have any frame. And in a classic way, that is all flush doors, for instance, door handles, that will be helping basically the drag coefficient of the car by reducing it. So in fact, flush handles of doors are nothing to do in general with electrification. This kind of system existed long ago in many other systems, in many other cars. And I did find this example of Fiat Barchetta from the 90s that had a mechanical based system that was already available. Electrification also, I think, to my mind, it means eco-design. So the use of recycled material has been heavily marketed by manufacturers. We do observe it in door isolation, in door panels. And ironically, on the MX-30, you will not find any sort of sound proofing isolation. They don't have that on the MX-30, probably because the inner panel of the door is made of this sort of fabric that is coming from recycled plastic bottles and contribute to the overall soundproofing of the car. So it's best way of saving is to remove, so you don't have any insulation sheet. And here they reuse recycled materials, so I think it's an interesting story. I'll drop this one and maybe ask the question just as a joke, obviously, that maybe the best doors are no doors. There are also cars that are offering this option. Obviously, you need the door, but something that we're not used to in Europe or even I believe in Asia, but in the US and on products like Jeep, you are used to this kind of fancy feature that cars are designed to enable their drivers to remove the doors at all. You have quick release trims in the pillars to disconnect the harness of the door, or storage for the bolt on the hinges of the door in the rear of the pickup truck. And I think it's funny to see that exists, that creativity remains even in door design, even is to say I design the doors for the doors not to be there eventually. Yeah, I think it's a cool experience it takes, as it seems, for 10 minutes with two people to remove all the doors and put them in the pickup area of your car. All right, that's it. A journey through door design, from technological features to manufacturing, and having the mega trend of transport and mobility in mind. If you want the presentation, as I said, here is my email address. Please email me from a professional email address of yours, not a Gmail or Outlook.com. It's something that relates to your job. I simply need to do that for compliance in my company, to know that we are talking not to competitors, for instance, but people who have a genuine interest in what you can learn from it and what we do.